Hello guys. So today I am going to solve another question on graphs, which is distance from the source, Bellman-Ford algorithm. Okay. So what we have to do actually, basically, given the edges. Okay. So 0, 1. So you can obviously get information that 0 is the starting vertex and 1 is the ending vertex of an edge. Okay. And 9 is the weight. And source is 0. So we have to give the distance from source to each and every vertices. Okay. So as you can see, from 0 to 0, the distance is 0. And from 0 to 1, the distance is 9. So the output is in a vector, obviously. In a vector, we have to give 0 and 9. And in this example, here again, all the information of the edges and weights are given. Source is 2. So from here, 2 2 to 2 itself distance is 0, so here it is 0. Okay, and from 2 to 0 the distance is 1, as you can see here 1 is given, and from 2 to 1 the distance is, we will cover this path 1, and from 0 1 5. So 5 plus 1 is equal to 6. So what I will do is, basically, first of all I will take a vector and initialize it number of vertices, and the initial value will be 1e8. Okay, not int max, as it is given here that if some node isn't possible to visit, then the distance should be 1e8. So it is actually quite larger value, so I am taking int max as 1e8. Okay, now taking my favorite variables aj and k. Now in a directed graph, from any vertex to vertex, the maximum edges that can be taken as v minus 1, where v is the number of vertex. So what I am trying to say, that from reaching one vertex to another, you have maximum distance of v minus 1. So I will run a loop to v minus 1. Okay. Now again I will run a loop from I equal to 0 to I less than addend. So it is the number of edges. Okay. Now, actually, Bellman-Ford algorithm is a dynamic programming. Okay, here the concept applies dynamic programming. So what I will do in here is, I take a vertex adjoint of J0. It is my source or the starting point of a vertex, starting point of an edge. Okay, and V, oh, sorry, V is already there. So I will take as Vi. Adjoint of J of 1. It is the ending of an edge. And WT is the weight of the edge. Okay, adjoint of 2. Now, if V of U is not equal to 1e8 and V of, oh sorry, I have to read. V of U plus WT is less than V of VI, then V of Vi is equal to V of U plus WT. And here I will return V. Okay, so let's run it. Oh, here I have gotten a segmentation fault. So this will be J. Okay, sorry for the mistake. It will be J plus plus. Again, I am running. Oh, actually, I think there is some mistake again. V of U, V of U plus WT is less than VI. V of Vi. V of Vi is equal to V of U plus WT. Okay, so return V. One second. Oh, another mistake. So source to source distance will be zero. I have to initialize it. Okay, at the starting point only. Okay, so the okay minus to the same problem. So I am here giving you one insights. So let's suppose. Uh, okay, so thank you.